So now that we know a little bit more about stress and strain and axial load and how we can use all of these things in combination together, we can do something really exciting, which is work with what we call statically indeterminate systems. So you may have heard me or your other statics professor talk about something being statically determinate or statically indeterminate while you were in statics. Right, so statically determinate, that is anytime we had something in statics that we could actually solve. So something statically determinate would be like just a beam that's pinned on one end and has a roller on the other end. Right, so this was a problem that we commonly solved in statics, finding reactions for those things. If we drew a free body diagram of this, you would have a Y reaction, an X reaction, and a Y reaction at the roller. So that's three unknown reactions, and we have our three equilibrium equations that we could apply, right? Our moment, sum of X forces, sum of Y forces. So with that, we would call this statically determinate, meaning we could solve it just using statics, as we did a lot during statics class, right? Statically determinate. But now that we know a little bit more in strength of materials, we're going to be able to solve things that are statically indeterminate. So things that we weren't able to solve in statics, we're now going to be able to start solving in strength of materials. So, for example, if we had a beam with, let's say it's fixed on one end, and maybe it's got a roller here and a roller here. So it's sitting on two rollers, but it's fixed on this one end. So in our free body diagram, a fixed one would have a moment at one end, an X force and a Y force, and then each roller would create another Y force. So we would have 5 unknowns here. 5 unknowns, but still only the 3 equilibrium equations to work with. So we would call this statically indeterminate. Statically indeterminate. And the degree rating that we call something statically indeterminate depends on how many unknowns you have versus how many reactions you can use, how many equilibrium equations you can use. So here, since I have 5 unknowns, but I can use my 3 equilibrium equations, we would call this statically indeterminate to the second degree, right? There's 2 degrees of separation. 5 minus 3 is 2. 2 degrees of separation between our unknowns and our equilibrium equations. So that means that we would need to come up with 2 more equations to relate things together. Right, so this can be valuable when we're trying to decide how many equations we need and set up additional equations. So let's take a look at a couple more, right? Maybe we have something like this. Here's a beam and he has 3 wires coming off of him, going directly vertical. And then maybe a load of 15 kilonewtons, right? So this would be 3 unknowns, 3 unknown cables, but note that we don't actually have 3 equilibrium equations we can use here, right? There are no X forces involved whatsoever, so we can't actually use our sum of X forces equilibrium equation, right? Sum of X forces equals 0. So that makes that equation null and void. The only equilibrium equations we can use here would be our sum of Y forces and our moment. So we actually have 2 equations, right? The sum of Y forces and the sum of the moment. So here, this is still statically indeterminate, right? Statically indeterminate. And we'll notice that we'll notice that we have 3 unknowns and 2 equations, so the difference there is just 1. Statically indeterminate to the first degree. This level of degree is what you'll see most in what we're starting to work with in these first few problems that we're going to look at. We're going to be dealing with statically indeterminate to the first degree type of problems. So you might see something that looks like this, where you don't actually have 3 equations you can use, you only have 2, and you still have to come up with that other problem. Or it could even be something like this, our axially loaded member, let's say maybe 500 newtons or so, and it has an A reaction and a B reaction, right? A reaction at each end and a 500 newton applied load in the middle there, or at some offset. Let's say it's at some offset point. Right here is where it starts, maybe 1 meter from A and 3 meters from B, something like that. So now in this one, we have 2 unknowns. But again, we only have 1 equation we can use, right? Our sum of x's isn't going to help us, and our moment isn't going to help us either, because the moment, all of these forces are through the line of action, right? So if we took a moment, all of the moments would be 0. All of our x forces would be 0. The only equation we can use here is sum of our y forces equals 0. That's the only equilibrium equation we can use. So again, statically indeterminate to the first degree for both of these. We're going to have to find another equation so that we can bring everything together and solve it. So this is kind of the introduction to what the idea of statically indeterminate is. If you didn't talk about it too much in statics, this is what it is. And in the next couple of videos, we're going to be talking about a couple of different methods you can use to solve these problems.